10.4 is about ellipses. What you can see is the standard equation of your ellipses. Okay, a horizontal ellipse is the first one, vertical ellipse is the second one. And what you have, do you know the difference? Notice how A is in the x-coordinate, A is in the y-coordinate. Well, if you look over here, A is bigger than B, A is bigger than B. So the biggest number is what coincides with your vertices. The smaller number is your covertice. And the foci we'll talk about in a couple minutes. Now, what's the equation in standard form of the ellipse center at the origin with vertex negative 6, 0 and co-vertex 3 and 0? See how the bigger numbers under the A, or on the x-coordinate, I'm sorry. And I know it's a negative, but you're looking at the absolute value of it. So A is going to be 6, B is going to be 3. Okay, so if I'm writing this here, so A squared then is 36, B squared is 9. So if I'm writing my formula, if you go back and look at the formula, x squared over A squared plus y squared, so we're going to do x squared over 36 plus y squared over 9 equals 1. There's your equation of your ellipse. To be able to graph this ellipse, given this equation, and to find the foci, you need to know what A and B are. So we're going to divide by 225, because if you notice in the last equation, it equaled 1. So it has to equal 1. So I'm going to divide everything by 225, and when I reduce my fractions, I end up with x squared over 9 plus y squared over 25 equals 1. So let's find my vertices and my co-vertices first and foremost. Now, where's my bigger number? It's under the y, so that's going to go in the y-coordinate. And plus or minus 5, it's 2, it's 0, 5, and 0, negative 5, but you just write it as 0 plus or minus 5. The co-vertex then, since it's under the x, is plus or minus 3, comma 0. So that's how we're going to graph it. So we're looking at this here, graph, and we'll deal with the foci in a second. Plus or minus 5 on the y is up here. And negative 5, 1, 2, 3, 4, 5 is down here. Okay, so there's my vertices. My co-vertices are plus minus 3, so 1, 2, 3 is here. And 1, 2, 3 is here, negative 3. So for graphing the ellipse, it's kind of like that. I'm a terrible drawer, especially on this thing, but I apologize. That's what it is. Now, let's find our foci. Okay? And to find the foci, that's your C value, and it goes C squared equals A squared minus B squared. You're kind of thinking Pythagorean theorem, a little bit different, but it's along the same lines. So let's figure out what that is. C squared equals A, which is 25, minus B squared, which is 9, gives me 16, so C is plus or minus 4. And the foci are on the same axes as the vertex, so since the vertex is on the y, my foci is 0, 4, and 0, negative 4. So if I'm graphing that, it's up here, and then negative 4, which is down here. Okay, so that's where my foci is. Example 4 wants to know what's the standard form of the ellipse shown. So they give me the vertexes and they give me the foci, and they wanted me to go ahead and write my equation. Okay, so my A then is going to be 8, and my C is going to be 5. We don't know what the B is, but again, we're going to use that same formula. C squared equals A squared minus B squared. So 5 squared equals 8 squared minus B squared, and let's solve. Okay, so we get 25 equals 64 minus B squared. Subtract 64 over, you get B squared equals 39. Negative B squared equals negative 39, so in other words, B squared equals 39. Now, obviously the square root of that doesn't come up, but we don't really need that because we're not looking to graph it. So we have B squared, which is 39, and we know A squared is 64, so we can use that to write our equation. So it's x squared over 64 plus y squared over 39 equals 1.